ANDing. When would I do ANDing? What is ANDing? And how do I do ANDing? Three very good questions we're going to try to answer today. ANDing is nothing more than the math used to determine whether an IP address is local and should be ignored in favor of the MAC address and switch, or whether it is remote and must be passed on the router to be sent to the destination host. In order to do that, the sending host will take its IP address and AND it with its subnet mask. This results in a network ID. Then the sending host will take the IP address of the destination host and AND it with that subnet mask. If the results match, the IP address is local and the file will be passed on to the switch for delivery. If the results do not match, then the IP address is remote and will be passed on to a router for transport to the host network. Let's take a look at our ANDing formula that we will be using. It's a different math than you are used to, but it's really easy to understand. What is ANDing? The 0 plus 0 equals 0, 0 plus 1 equals 0, 1 plus 0 equals 0, 1 plus 1 equals 1. So 3 out of the 4 possibility gives us zeros, which in binary means no or turned off, and only one of the 4 gives us a positive, or 1, which means yes or turned on. Are these two IP addresses on the same network? 192.168.1.5 with a side of 26, and a subnet mask of 255.255.255.198, and a destination IP address of 192.168.1.40 with a side of 26, and a subnet mask of 255.255.255.198. Our binary formula, 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0, all with the mathematical equivalent. We can use this binary power of 2 formula. We will use this formula in the subnetting video also. So 192.168.1.5 with a side of 26, subnet mask 255.255.255.198. Let's remember our formula. 0 plus 0 equals 0, 1 plus 0 equals 0, 0 plus 0 equals 0, and 1 plus 1 equals 1. When we do that, this is what we get. We reduce the dotted decimal to a binary. We do that by subtracting from our formula up above. We take 128 from 192, and that leaves 64. So we turn that on. 64 goes into 64. Yes, all the rest are turned off. Now we go to the second octet, 168. 128 from 168. Yes. Does 64 with the remainder of 40? Does 64 go into 40? No. So it's turned off. 32 goes into 40? Yes, it's turned on. 16 go into 8? No. 8 goes into 8. That's turned on. And we do that for the rest of it. Then we do a 255, 255, 255, and a 198. So then we add and them together, and we get this. And when we turn that back into a dotted decimal, we get 192.168.1.0. So that's our subnet network ID of 192.168.1.0. We do the same thing for the destination. 192.168.1.40 with a side of 26, 255.255.255.198 for the subnet mask. We turn that into binary using the above formula. Again, 192. 128 goes into 192. Yes. With a remainder of 64. 64 goes into 64. Yes. And all the other ones are zeros. And we do the same for each octet. We then do 255, 255, 255.198. Turn them into binary. Then we do the ANDing, and this is what we get. And when we do that in dotted decimal, it turns out to be 192.168.1.0. so the two IP addresses are on the same subnet. We can double check this by looking at the magic number. A /26 means that 26 bits are used for network. Remember our formula. The third octet ends at 24 bits, so we borrow 2 from the fourth octet, bits 25 and 26. Bit 26 occupies the 64 spot, which means our network changes by 64. 0 to 63, 64 to 128, 128 to 255. So in summary, ANDing is what computers use to determine whether an IP address is local or remote. We do ANDing by reducing the dotted decimal IP address to binary bits. ANDing can mostly be used as a check on our subnetting networks. This has been the ANDing video. Thank you for watching.